Section 3.3 and 3.4, we're going to talk about multiplication and division. Section 3.3 is sort of the conceptual idea about what multiplication does and a division does. And then 3.4 is going to talk about algorithms or methods, ways of doing that particular operation. Okay? Just like 3.1 and 3.4 kind of split it up. So to start with, multiplication of whole numbers. For every whole number, A and B, when we talk about, one more condition. We've got n is not 0. So put n as not 0. So when we talk about n times A, this means having A added to itself multiple times. There are n A's here. And if n does equal 0, then n times A is 0. So the B comes into play in the second part of this description. So then if you have n of A is the little number A, and n of B is the little number B, and you talk about taking A times B, this is the number of items in the cross product that we encountered in, Cartesian product that we encountered in Chapter 2. i.e., and this is where we actually saw it, if you take the number of items in set A and you multiply by the number of items in set B, you get the number of items in the Cartesian product, A cross B. Okay. One way people talk about multiplication is they talk about it in the sense of what I sort of wrote out up here. All multiplication is repeated addition. It's just a condensed way of saying, I want to add the same number to itself a bunch of times. And that works fine when we're working with whole numbers. So that's sort of where we start with the idea of multiplication. So let's talk about some models for multiplication. The first one, which is repeated addition. Okay? So I've got some examples of these models. So the first example for repeated addition would look something like this. Jessica takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? So the answer, of course, is 3 times 4, but the real idea behind what's going on is that she has 3 this Friday, and 3 next Friday, and 3 on the 3rd Friday, and 3 on the 4th Friday. But we don't really like to write that out a whole bunch of times, so we have this condensed way of thinking about it called multiplication, 3 times 4, and the answer, of course, would be 12 tests. Okay, we're repeatedly adding the same number. The next 2 models, one's called array, the one right after it's called area, are pretty much the same model. However, this one is used for sets, that is things that can't be sort of subdivided, okay, whole number things that absolutely have to be whole numbers, like when you're counting people. You don't count half of people, right? You don't do that. So this idea of sets would be something here. If you were counting something that can be subdivided, things like when we were doing the number line models and talking about lengths of things, that's something we're going to use in the next part of the problem, next problem on the next slide, which is area. So this is used for arrays. For example, Marty is baking cookies. He's able to place the dough 3 cookies wide and 6 cookies long on his pan. How many cookies will his pan hold? So if you were looking at sort of drawing a picture of what's happening here, which is a good argument to do, especially when you first start looking at this idea, you would have 3 cookies wide. And you should have it 6 cookies long. So there's 4 cookies long, and I'm running out of space, so I'm going to just put mine on top of my words. So there you go. So we have 3 cookies wide, 6 cookies long, and you can see from a picture sort of point of view, what in the world would this give you? This would be 18. So we're talking about 3 times 6 here. That's a 3 and the 6, and this is 18. But you can see this picture looks very different than writing out 3 plus 3 plus 3 plus 3, doesn't it? I mean, it is. We could say 3 plus 3 plus 3 plus 3 plus 3 plus 3 going down my rows. But that's not the visual picture we have when we're talking about this diagram at all, right? This is the visual that we're pulling up, which is an array model. All right, so an area model Again, like I said, it's used for things that you can measure, so things like feet or like cups of flour or whatever, things that you could actually subdivide and it would still make sense, not like the people. So Alexis is planting a garden. She has a space that's 5 feet 5 feet wide and 7 feet long. How much area does she have? And if you were doing this one, you could actually draw a rectangular grid. So 5 by 7, so it looks something like this maybe. And you could even talk about sort of partitioning it off if you wanted to count, right? So you could actually say, oh, let's just split this down here so that we can see the 5 wide. So there's 5 wide. Okay, it's not completely perfect. In fact, it's far from perfect, but it's not bad. So we have 5 wide, and we have feet wide, and we have 7 feet long. So we end up with 5 times 7 to giving me, and if you counted the little squares, it would be 35. And when we're multiplying feet times feet, we would get feet squared. So this is actually 35 square feet or feet squared. Okay. So looking at this, you kind of see how it looks like the array model, right? But you're doing it for a different type of a number. That's the difference. All right, so here's what you guys are going to do next, and we have just enough time to do it. We did this before. So we'll just do it where you're sitting because we're pretty close to having pairs where we're sitting. The person across the aisle from you is your partner, and we got one partner, a group of 3 in the back, ladies, right? I think. No, Audrey, why don't you come in? You can be with Taylor in front of you, okay? Because then we have an even number. All right. So what you're going to do is you're going to go through these 3 different types, and you're going to create a question. So you're coming up with 3 questions between you and your partner, and then we will end with you guys telling me what your question says for each of the ones we do, okay? All right, so somebody give me an example of what you did for repeated addition. Yes?
You put Bob eats 5 cookies in a week for 3 weeks. How many cookies did he eat?
All right, so he eats 5 cookies a week for 3 weeks. How many total cookies did he eat? One more group for that one. What did you do for repeated addition?
Said Carly takes 2 shots every Thursday. After 5 Thursdays, how many shots?
All right, so she gets 2 shots a week, and after how many, after what was it?
5.
After 5 weeks, how many shots has she had? Good. All right, what about an array model? What do you guys have for an array?
We put the desks are arranged 4 wide and 2 deep. How many desks were there in a row?
Good. That's a good visual one because kids are often arranged with desks. That's great. What else? Someone else for array.
We said Sarah's planting flowers. She wants 2 rows of 12 flowers in each row. How many does she plant?
Very good. So we're planting flowers in a row. All right. How about area then? That's our last one. What do we have for area?
We had Jim opens a store. The space is 15 feet long, 17 feet wide. How big is this store?
Good. So we've got the length and width of his store. And then we have one more problem. Which group hasn't talked? Was it yours, Sabra?
Read it, but we didn't get to it.
Okay. So so for the idea for area, something else maybe we could do instead of something spacing in a store. Another one that I've had people have given me before has to do with wallpaper on a wall. So instead of sort of the floor space, they did a wall space, which was a really nice one. You could also talk about the space on a chalkboard, which would be a great visual in a classroom for students. So, all right, we will pick this up next class.